Okay. And then Peggy, you are up next. Peggy Selvin, again, is going to talk about sonar ice data, telling us a story about the seasonal dynamics of ice formation. All right, let's see. All right, Peggy, let's see. Sorry, I have to find you in two spots here. Okay. All right, Peggy, you should now be unmuted. And then I'm going to move presenter to you. Sean, I'm muting you now. Okay, Peggy, I can't hear you yet. There we go.
There, I unmuted myself.
Perfect. Sorry. Yeah, I never know how exactly if I'm truly muting people or something. But perfect. Okay, I'm going to unmute and you can take it away.
All right, thank you, Heather. Good morning, everyone, from all of our remote locations. I have the benefit of having a sunny window instead of an interior office. Woohoo! I'm going to be talking about Chukchi Sea ice, and Chukchi Sea is a marginal ice zone. So ice all winter, ice cover, and open water all summer, with shoulder seasons being transition seasons from waves to ice and then from ice to waves. The Chukchi Sea has seen really dramatic warming and sea ice changes in the recent years. So it's fortuitous for us that we have a long set of data to look at some of these changing areas. Next slide. All right, I'm working on controls. There it is. This is the area that we're working on. On the map, the 7 stars are stations where we've had ice profiler moorings set out, and I'm actually going to be talking and have looked more at the 3 that I've just circled, C1, C2, and C3, which we call the Icy Cape line. That line was located because of proximity to the Alaskan coastal current and proximity to Hannah Shoal, which is probably a little further off than the label on the map, but you can kind of get the sense of that. We do fall deployments and recoveries, and so have almost full years of data for each mooring that we pull back. We get ice draft as the main data product. Now, ice draft is very related to ice depth, but what it really is defined as is as the surface of the water down into the depth of the water. It does not account for ice from the surface and above, and it comprises about 90% of the depth, but it actually is draft. We would have to do further instrumentation with ADCPs to actually get depth, and we haven't done very much of that. In addition to the range data that turns into ice draft, we also have temperature and pressure data. And at each of these stations, we have not only the ice profiler mooring, but also many other moorings that capture salinity, temperature, and other parameters that we frequently get, like oxygen and PAR and chlorophyll and nutrients, etc. C2 location has the longest running data record. We started putting these out consistently in 2010, and C2 has been out almost every year since then. So there are 9 data sets for C2, 4 data sets for C3, and 7 for C1. And this table gives you a sense of what I just said. C2 is the longest running, and then the other ones were earlier years, and I haven't done as much with those. But in sum total, we have 9 years worth of moorings, 29-year long data sets, and have only lost data from 2 years of instruments, so about a 7% loss. And it wasn't really loss of instruments, it was problems with the instruments themselves. To the left of the screen, you can see some information about the instrument. They're from ASL Environmental, and they're called IPS-5, upward-looking sonar instruments. I think we were kind of unique back in this time in that ASL was mostly, if they weren't deploying their instruments, they were absolutely taking the data and processing for whomever was paying for it. And we pushed them to get their software so we could process the data ourselves. And it was kind of a big undertaking. It's a proprietary MATLAB tool. It's pretty large, and it really takes months to get through a data set. So we are a bit of guinea pigs for them, but it's been pretty cool working for the data, or working with the data and with them. This illustration is one of the first cut products that I make when I'm done, when I finally get from the range data, raw data, into the ice draft. And this is kind of an upside down look. The zero line there is the surface, and you're seeing the spikes that go upward are what go into the depth of the water. Each line of the 6-line plot is 1 week long. So it gives you a good sense of the variation in how the ice looks underneath the surface, where you get all the chaos, spiky things, and then you'll get some flat segments that are actually pancake ice or frazzle ice or thin surface ice between the larger ice events, or the stretches of ice. This is a later product that I make, and it actually is a very long-term record. So you have to remember that these are 1 second data points. So the instrument's sitting at the bottom and looking up at the same spot and watching anything that goes by, and every second it's taking a measurement. So if you look to the left of this plot with the blue lines, you're starting in mid-November. To the right, you're ending at late July. So you're seeing to the left summer waves damping down, and then all the chaotic looking lines through the middle are a formation of ice, and then ice cover through the winter. And then about 3/4 of the way along this plot, you can see a blob there where the blue is above and below the zero line, and that is a big wave segment that has come in, signifying the breakup of the ice over the winter. This is due, of course, to increased solar insolation, warming, and winds. And so eventually it seems kind of like a duel to me, where the winds come in and they fight with the ice until the winds win, and open water for the summer. If you look at the last, I don't know if you can see my mouse here, the last segment of spiky stuff that goes below zero, that is ice. So it comes after wind, and this is a really frequent thing we see, and it signifies not ice formation, but ice coming through with breakup elsewhere in the region. And then after June 4, you see the above and below zero signal that is all waves and open water. Ice keels are really important, and when I first started looking at these data, that was one of the main things we were looking at, was how deep can the ice keels be? And we were trying to answer questions like, is ice going to come through and destroy the instrument that we have as near to the bottom as we can? And at the time, Shell and some of the oil companies were also up there, and there was some concern about things that they were putting in, and would problems be created by ice coming too deep and hitting things that were near bottom? And we were kind of happy to be able to quantify this, and I have listed here that the deepest keels that we have seen are 28.6 and 31.1 meters, and this is down where instrument depths are between 32 and 40 meters, so it comes fairly close. Now, this is not all the time, but it's often enough, and enough of a liability that, it was a great thing to report to both researchers who are putting instruments in, but also to oil companies that, where liabilities might exist for putting things in the water. Another thing that I've been looking at with this is seasonal transitions. So you have summer open water, winter ice cover, and then you have the transition time where you have a chaotic mix of waves and ice coming through. Generally in the fall, the transitions are much more orderly. So you get a strong sense of when things stop and start. Spring is much more chaotic with lots of starts to wind, and then ice will come back pretty solidly for a while and back and forth, back and forth. I've made this illustration. If you look at the blue, that's open water for the summer. The light blue is ice cover, and the red is the transition zone. And essentially, it shows this trend of the transition coming later and later. I mean, the duration of the transition is seasonal. It's just variability from year to year, but the transition to, or the evolution to this event, or this transition happening later and later every year, is pretty obvious. And it very closely, it's correlated with the satellite ice concentration data. Now I'm looking at my time. This is just another close-up of some of the snapshot of the data, but it shows you spring transition. And even though I just said spring transition is longer and more chaotic, this is a really fast one that occurred. And if you notice in the top plot, it's 2.6 day duration. And so to the left, you're seeing the ice tendrils going down. And to the right, you're seeing the wave signal. And they're zoomed out on the bottom. It goes from the top is a 2.6 day view. The bottom is a 2.7 hour view of this transition from ice to waves. And I've taken the opportunity in this plot to show you what ice formation and frazzle ice, thin ice looks like. The tendrils are ice, of course. There's a wave thrown in there in the center that helped break up the ice. And then I'm showing you ice keel, which is probably something that came through from elsewhere because it's a transition from winter to summer. And then to the right of this plot are all waves, and is the start of the summer open season. And then kind of off on a tangent, but this is something we're looking at right now with Catherine Burchak over at AFSC, the Cetacean Assessment and Ecology Group. She noticed in some of her walrus data, they've got hydrophones up there, that just a couple of times that there seemed to be a pattern of having a daily maximum ice signal followed fairly quickly by a heightened signal of walrus in the area. And so we've plotted the daily maximum ice draft, the walrus data, and satellite ice concentration here. And to do a blow up of what we're looking at in April of 2011, the black in the add-on plot there, the black is the ice signal, the red is the walrus signal. And so there's some conversation and thoughts about going forward about looking at correlation between the presence of walrus, what the ice looks like, whether there's open ice before or after the peak in the ice segment, and also how the winds might impact all this. I think I've just covered all that, and that's it. So the data analysis and processing are ongoing. We didn't have data in 2019-20, but we hope to have one going out this summer. Maybe, we'll see. We're working on a paper that will talk about seasonal changes and the wind-ice polynya interplay. Collaboration with Catherine Burchak at AFSC regarding the walrus. And I actually have a web area that is outside of our Drupal, but it's Ice Profiler and Ice Draft Plots. And it's under Ecofoci. So any questions are welcome, and thanks very much for listening.
Thank you so much, Peggy.